Okay, recording to the cloud. Yes, yes, yes. Good, good. Okay. So, no one has heard of Pasco or capstone, or those words don't ring any bells. So, what I'm going to do is I'm going to show you everything you need to know. So, what we're going to do is actually I'm going to uninstall this application from my computer. What is it called? Pasco. Pasco, Pasco. There we go. All right, it's in trash. No other files probably. Okay. Now I'm going to head over here, and this is right here in this little tab. And for me, I have a Mac, so I'm going to do this. I'm just going to put it on my desktop. Okay. And I'll make a very short little assignment, and put that into its own little intro folder. Can kind of serve as like a pre-lab assignment. But I'll make it optional. This stuff is, you know, it's not rocket science. So if you'd like to skip it, that's quite all right. But well, I'll make it extra credit in the sense that, like, how about we do like 5 bonus points on lab 1? Let's do that. Continue. Agree. That's a lot of space, but I need it. All right, there we go. I'll delete that later. Look at that. It's already here. Hello. Okay. Maybe let's try opening a file. So once we have that, we will need this at some point. So what we just downloaded was a free trial. I believe the website said 60 days, not 30. So this is maybe an old. Okay, it stops jumping. Now it's jumping like it's open. Okay. Now what we need to do is somewhere put some kind of key in here. Let's figure out where it is. There we go. So what I did there on my Mac, I'm sure it's somewhat similar for PC. I just went to About. I just got lucky to find it that quickly because I installed this many years ago. I think I've done this before, uninstalling it for the first day. So enter key. I'm going to copy and paste my key in there. And now I don't have to worry about any kind of monthly trial business. Okay, so now I'll show you this little assignment that I want to give you. Basically, what we're going to do is we aren't going to work with this. This I will, in that first 20-ish minutes or 30 maybe for the first day, intro for the first lab, I'll go over this and explain how this is taking data. This is more or less entirely in this hardware setup. So right now I'm not in the lab. I can't show you, what it looks like with that. But we'll do that on the first day. So what we're going to do is we're just going to take some data. That's not what I meant. Not take data. We're going to be given data. So I'm going to provide you with some data, and you are going to open it. So what you're going to do is you are going to read through this thing, and we're only going to do part 1 of this document. So it just kind of familiarizes you with everything, all the little buttons and what they all do. Once we get here, what we're going to do is open a pre-existing capstone file. So I'll put it like right here. I'll do like lab 0. I'll put a little thing right there. And there will be a file right here, and you're going to download it. Just clicking it probably won't open in Capstone. You save it somewhere. Like for instance, I will put mine here, and then I will open this. So this is what you're going to get. This is the file. And you're going to open it, and it will have a table full of data in it, ideally. Let's maybe close this window. No, I don't want to save. Open this. There we go. For some reason, it was just defaulting to the main one. So this data is not the same data as this person in this lab manual is talking about. So their plot at the end, this is the result that I'd like you to submit. Their plot at the end is going to be testing. So what are we testing here? We have a bunch of forces and a bunch of distances. So what we're looking at is Hooke's law. This is that the further away you stretch a spring from equilibrium, the more the full force pulls back in the opposite direction. So if we were to think about this in terms of lab, if we hang some mass and that exerts some gravitational force, now we know what the force is, and we can visually measure the distance. So we change the mass, changes the force, and the distance changes. So this is, in this particular form as it is right now, the way I just described how that lab would work, it would actually be the force that was the dependent variable, and x would be the x would be dependent because it changes depending on how much mass we put on it, and the force due to the mass we put on it, that would be the independent variable, the thing we change, and then we observe what the secondary variable does. So for this one, we're just given data. It's not, we're not taking the data, we're just being given it. So we can choose which one is the independent and dependent variable. So in the form of Hooke's law, as it is right here on the screen, the most common way, F equals negative kx. If we make this a graph, y, what's the equation of a line? Y equals mx plus b. So for us, the plus b is basically almost all the time in lab, the plus b is just error. Ideally, this is the equation we should see. And if we see any plus b, it just means there's some sort of error and it's not centered or something like that. It doesn't go all the way down to zero. You know, we're not setting up a perfect experiment. But what we can do is use the slope, the m variable, to learn what the spring constant of the particular spring we're working with in lab is. And so that's what we're going to do with this data. You're going to read that document, figure out how to make a graph. It's very, very easy. Maybe I'll stop this recording and do a second recording just in case after the first lab, if no one has done it. I imagine, I mean, it's 5 points in the first lab. I imagine I hope most of you would do it. Then I'll show you the solution, you know, how quickly it is to do this. It's very, very, it's about 30 seconds. So yeah, just go through that document and I'll make a small assignment right next to it in this little folder right here where you can submit for some extra credit. So let me know if any of that is challenging. This download and license key seems to be pretty straightforward. All right.